Hello everybody, welcome back to Calculus 1 online at FCC. In this lecture, we will discuss derivatives of inverse trigonometric functions. There are 6 formulas that we need to know for this topic. And just like with trig functions in our previous lecture, we're not going to describe the whole process of developing each formula. While that process is important, I don't believe it's necessary for students in this class to understand how to apply these formulas. So if you are interested in seeing the rigorous process of developing these formulas, definitely reach out to me. But in general, I don't focus on that particular step. So here you see 6 formulas. And you might have noticed that I grouped them up in such a way that the first column, the one on the left, has all positive expressions for the derivatives. So here we have derivative of sine inverse is positive 1 over the square root of 1 minus x squared. And then the derivative of tangent inverse is 1 over 1 plus x squared. And the derivative of secant inverse is going to be 1 over absolute value of x times the square root of x squared minus 1. Okay, and notice that the derivatives of cofunctions, so that's arc cosine, arc cotangent, and arc cosecant, are very similar. The only thing that's different here is the negative sign, so we have negatives over here. All right, so it is a nice way to group these derivatives and kind of notice a pattern here. Okay, so once again, you will need to memorize these formulas or have a formula sheet in front of you as you go through solving problems either on homework, quizzes, or exams. Now, in addition to knowing these particular formulas, we need to keep in mind that we will also need to remember all the other rules. So the derivative of a sum and difference, the constant multiple rule, product and quotient rules, and most importantly, the chain rule. Okay, so what we're going to do in this lecture, we're going to solve 6 problems where I pick one of each of these functions. And we're going to carefully go through the process of computing derivatives. So let's go ahead and get started. So here's our first example where we would like to compute the derivative of sine inverse of the expression 3x squared minus 1. Let's discuss the solution to this problem. So here I am reminding you what the general formula is. So the derivative of arc sine of x is 1 over the square root of this difference, 1 minus x squared. Now in this case, my function has an argument of 3x minus 1, so you would plug in that expression everywhere we see x in the formula. So this is going to be 1 over the square root of 1 minus the expression 3x squared minus 1 squared. And of course, we do not forget about the chain rule times the derivative of 3x squared minus 1. Okay, so this is your first example to notice that we have to use the chain rule here. Okay, the derivative of 3x squared minus 1 is easy to compute. That's 6x. And the final answer is going to be the following expression, 6x over the square root of 1 minus 3x squared minus 1 quantity squared. And you might be wondering if you should multiply this through. And the answer is you can if you would like to and carefully simplify, or you can just keep it as is. It is completely fine. It will be accepted for completely full credit, both on homework, quizzes, and exams. Okay, so the final answer here is 6x over the square root of 1 minus 3x squared minus 1 quantity squared. Let's take a look at the second example. Here we have y equals to arc cosine of the expression 9x cubed plus 5. So just like in our previous example, the first thing is for me to write out the formula, and this is going to be negative 1 over the square root of 1 minus x squared. Except in my case, the argument of the function is not just x, but rather a function of x. And that means we will be applying chain rule. So the first step is to apply the formula over here. And notice that I plug in the argument everywhere I see x in the formula, then times the derivative of the argument. Okay, once again, the derivative here is easy to compute, so that is 27x squared plus 0. That's where this expression comes from. Okay, over the square root of 1 minus 9x cubed plus 5 squared. Notice that I keep it factored. I'm not going to multiply that square through. And of course, we don't forget the negative sign. Okay, so here is an example of computing the derivative of a cosine inverse function. Let's take a look at an example where we're asked to evaluate the derivative of the following function at the given point. So this is a problem that you might encounter on your homework or something similar to this. We have y equals to secant inverse of x, and x is equal to 5 over 4. So how do we approach this problem? The first step that I'm doing is writing out the formula. So the derivative of secant inverse is 1 over the product, absolute value of x times the square root of x squared minus 1. Okay, so that is my y prime here. Notice that the argument of our function is just x. We don't have to worry about the chain rule. However, let's say we were to apply chain rule, what would happen? So this would be times x prime, and of course we know what x prime is, that's just 1. So technically we could still apply chain rule here, right? Okay, so what is the next step? We're going to evaluate our derivative at 5 over 4. Okay, so I carefully plug in 5 over 4 everywhere I see x in my expression. So here's 5 over 4 in front of the radical. And then under the radical, we have 5 over 4 squared minus 1, which is 25 over 16 minus 1. And that gives us this number right here, square root of 9 over 16, which of course this is equal to 3 over 4. And what happens here? The 4 in the denominator goes in the numerator, okay, and that's where 16 comes from. And then 5 times 3, that's 15. So the final answer here is going to be 16 over 15. And let me just remind you what that represents. That represents the slope of the tangent line to the curve of this function right here at x equal to 5 over 4. Okay, so here's your first example where we're asked to evaluate the derivative, right? So evaluate, that means your final answer should be a number. Okay, let's take a look at our next example. Here we would like to compute the derivative of the function cosecant inverse of 1 over 7x plus 2. So this problem is not too complicated, but we have to be very careful when applying the formula, specifically because our argument is a ratio. Let's go ahead and take a look at the solution. The first step is to write out the formula that we're going to apply. So that is negative 1 over this product, absolute value of x times the square root of x squared minus 1. And now, keeping in mind that my argument is this ratio, I'm going to plug that in everywhere I see x in the formula. So this is what we have here, -1 over the absolute value of 1 over 7x plus 2 times the square root of 1 over 7x plus 2 squared minus 1. So this is just still following the formula. And then times the derivative of this expression. And this is where we apply chain rule. Okay, I'm going to abbreviate it as CR. Okay, chain rule. All right, so you see that this problem is just a little bit needy. This is what I call this type of problems where you have to pay special attention to all of the terms. Okay, so how do we compute the derivative of this argument? Well, the way I think about that is that this is expression that's equivalent to 7x plus 2 raised to the negative first power. And if I were to differentiate that, that will give me this expression right here. How so? So -1 comes down, okay, and then the power becomes -2, and also times the derivative of the inside by chain rule. So the derivative of 7x plus 2 is 7. So that's where this expression comes from, okay? All right, so now what? Let's go ahead and see what we can combine here. So this negative and this negative will give us a positive. And then 1 times 7, that's where this expression comes from here, okay? Now let's see what happens in the denominator of this expression. Okay, so 1 over 7x plus 2 cancels out with one of these powers right here. Okay, and now what I'm going to do, I'm going to bring this group 7x plus 2, just raised to the first power, under the radical. Okay, and once I do that, I have to square it because it's going under the radical, right? And what's going to happen? Again, it's going to cancel out with this term right here. So that's where this 1 comes from. And then 1 times 7x plus 2 squared, that's just this expression right here. Okay, so I know I kind of went through this fairly quickly, but this is just some algebraic steps, and I strongly recommend that you carefully go through all the steps, show all the work, and make sure that you get this expression as your final answer. Okay, and you can stop right here. You do not need to multiply 7x plus 2 squared through. Just keep it as is. That will receive full credit both on your online homework as well as quizzes and exams. Okay, so you will encounter some of these type of problems where the argument of our inverse trig function is a ratio. So we just have to be very, very disciplined in our writing and be very careful when writing out all algebraic steps. Let's take a look at our next example. Here we would like to compute the derivative of the function tangent inverse of square root of 2x cubed. So let's take a look at the solution. The first step is to recall the formula, and it is 1 over 1 plus x squared. And now we recognize that the argument of this function is a function of x. So we will need to apply the chain rule. Now I'm going to rewrite that expression as square root of 2 times x raised to the power 3 over 2. And that will make it a little bit easier for me personally to compute the derivative of that expression. Okay, so here on the first line, I am applying the formula. So it is 1 over 1 plus square root of 2x cubed quantity squared, and then chain rule over here times the derivative of the argument, right? So this is chain rule, and I'm going to compute that derivative on the next step. So square root of 2 is a constant, okay, and then we apply the power rule, so 3 over 2 comes down, times x raised to the power 3 over 2 minus 1, and that's where 1/2 comes from. Okay, so now we can clean this up a little bit. Root 2 over 2, that's just 1 over root 2. So I'm going to go ahead and bring it down here in the denominator. And then in the numerator, we just have 3 times square root of x. Okay, and there are a couple of different ways you can have this answer in an equivalent form, but this is fine. You can just stop right here. This would receive full credit. So again, I want to emphasize the importance of recognizing that the argument of our function here is not just x, it is an expression of x. So that means we will be applying chain rule. Okay, here's our last example for today's lecture. Here we would like to evaluate the derivative of the given function at the given point. And our function is 3, cotangent inverse of x, and x is equal to -1 over 5. Pretty straightforward. We just need to apply the formula carefully and then evaluate our expression. So let's take a look at the solution here. The derivative of cotangent inverse is -1 over 1 plus x squared. Okay, we don't have to worry about the chain rule here, but we do have this 3 over here that comes from the way the function was defined. We can just pull it out as a constant. Okay, so this becomes 3 times -1 over 1 plus -1/5 squared, and we carefully go through all of the algebraic steps, and the final answer is -75 over 26. All right, so let me remind you what this number represents. This is the slope of the tangent line to the curve of our function, 3 cotangent inverse of x, at x equal to -1/5. So of course you can always check that visually. If you plug that into a graphing calculator or Desmos, you should be able to see that at that particular point, our function should be decreasing, right? And the line that's tangent to that point should have a negative slope. All right, so this is our last example for today's lecture. I'd like to finish this lecture with emphasizing that these formulas will be important to remember once we start integrating functions. And that will happen close to the end of the semester, as well as all of Calculus 2 and 3. So if you plan to continue your study of calculus, definitely try to remember these formulas or have a formula sheet available for you. And at some point, you will be expected to recognize these different forms. Now, for our class, you may have a formula sheet on both quizzes, homeworks, and major assessments such as exams, but I do want to emphasize the fact that these formulas do show up a lot in your next courses of calculus. Now we'll stop here. Thank you all for watching, and I will talk to you next time.